Hi there guys, got a video here today on the Theoben Rapid, and what I want to do in this video is machine up a new barrel for the rifle. So with that said, we can get started, and the first thing I need to do is measure off where I want to put the new barrel. Now ideally I want the new barrel to be slightly shorter than the old one, and I want the end of the barrel to finish roughly in line with a bottle. So as you can see here, I'm just marking that off with a tape, and once I've got it marked off, I can move the barrel over to the lathe and get the excess cut off. Now the barrel that I'm going to be using to do this work is a Varrock 500mm long choked barrel. The OD of the barrel is 16mm in diameter, so it's a perfect candidate for the Theoben Rapid, as the finished shank will be around 15.9mm. So we won't have to worry about sleeving the barrel or anything like that. It should just need a quick skim and then fit into the block. But with the barrel cut to length, the first proper job is to get the breech end established. The first challenge we run into is that the ID or bore of the barrel is not perfectly concentric with the OD. You can see that in this setup here. We have the white face gauge showing the run out on the OD of the barrel, and the yellow face gauge is measuring the ID run out. The OD is running nice and true with only a very small amount of movement in the needle, which is probably just that the OD of the barrel isn't perfectly round. The yellow face is jumping around a little because we are measuring on the rifling, but you can see here that the range is typically between +2 and -7, so that's just under 0.1mm of total run out. What I need to do is get the ID running nice and true, so that when I cut the lead, the pellet will be pushed nicely into the center of the rifling and not off to one side. To get the barrel set up nicely, I'm using a bell chuck, or it's sometimes called a spider. So this device here allows me to control run out over 2 points so that I can get the bore perfectly aligned with the axis of the lathe. Now at this point I want to mention that this is probably a bit overkill for an air rifle barrel. 0.1mm of run out probably wouldn't make too much difference to the overall accuracy of the rifle, and if you didn't have a spider or a bell chuck, 90% of the time you could just chuck the barrel up in a 3-jaw and machine it as is. A slightly better way to do it would be to use a 4-jaw chuck or an independent 4-jaw chuck, so that you could dial in the run out over 1 point and get a slightly better result than the 3-jaw. The main downside of using a 4-jaw chuck is that if the bore of the barrel isn't perfectly parallel with the OD, there is no way to adjust for that. And that's the main reason I use the bell chuck. I can control run out over 2 points and get the bore of the barrel perfectly aligned with the lathe. But with that all said and done, we're pretty much done with the setup. Here's just a quick look at the run out once it's been set. You can see that the white face gauge is reading a small amount of variation, whilst the yellow face gauge is returning to the same point each and every time. Now whatever method is used to center the barrel, once it's set up I can start work on the external features. So the first thing we're doing is just facing off the end, cleaning up the part that we parted off earlier, then turning the OD to a snug fit in the block. I'm going to be using the block as a gauge for the fit, as the Theoben doesn't use any O-rings around the barrel to seal the joint between the block and the barrel. So the barrel itself needs to be a real good fit in the block so that air doesn't leak around the barrel when the rifle is fired. But that's nice and simple to do. That's just a little bit of plain turning, and once that's done, the magazine boss can be turned onto the end. With that done, the last thing to do in this setup is cut the lead. So the lead is a tapered start to the rifling, and what I'm doing here is just cutting a 5-degree taper in the end using a micro boring bar. I'm feeding around 0.1mm at a time, taking real nice shallow cuts. When it's finished, the lead itself should be 4mm in length, and the back of the pellet will be fully seated within the taper. And whilst I'm getting that cut, what I've gone ahead and done is mocked up an offset taper in CAD, so you can see how much even a small amount of misalignment affects taper concentricity. So what you're seeing here is 0.1 millimeters of radial offset, and as you can see on one side the rifling has hardly been touched, and then on the other a deep taper has been machined into it. You can imagine that if we were to feed a pellet into that, the rifling marks on the pellet wouldn't look very even, and that may affect the pellet as it flies through the air. Now, admittedly, some of this would be evened out by the choke, so it's not as dire as it would seem, but still something we want to avoid. But with that all said, after a quick 45-degree chamfer, the lead is finished and the pellet feeds into the rifling nicely. Right then, that's pretty much it for the breech end. With that all finished, I can start work on the muzzle end. To begin with, the blank was flipped around in the bell chuck, reset up, and with that done, the original crown was removed from the end just using our lathe tool. We're going to be re-crowning the barrel, so we don't need the factory crown, but that'll be done just after we cut the 1/2" UNF on the end. So the first thing to do is turn the 1/2" UNF profile. That involves just turning the end down to 12.7 millimeters, then cutting a relief groove for a clean end to the threads. With that done, the thread can be cut on the end, and then what I'm doing here is just using an old moderator back to check the threads. I typically use a 1/2" UNF go gauge, but I just wanted to show you that you could use a moderator end if you didn't want to spend the money on a go gauge. Right then, with that all done, the last lathe job is to put the crown on the end of the barrel. Now, I do all my crowns in exactly the same way. What I do is use a grinder set just above lathe center height and centered on the barrel in the left or right direction. What I do then is just use a cut-off wheel to grind a large radius in the end of the barrel, making sure that the grinder is cutting up and away from the center of the barrel. What this does is ensure that there's not a burr being pulled onto the inside of the rifling, and that the pellet should exit the barrel nice and cleanly. Now, at this point I do want to mention that there are loads of ways to crown a barrel. This way works very well for me. It's nice and quick and easy to do, and it always provides a clean finish. In my experimentation, I have not found crown shape to affect accuracy in a noticeable way. It is my personal belief that if the crown is cut nicely and that there is not a burr on the inside edge where the rifling meets the end of the barrel, the crown, whatever the shape, should work nicely. I will say though, that's just my opinion. You may have your own one. The last thing I always do with the crowns is just use a honed 45-degree chamfer tool to put a very small 45 in the end to finish things off nicely. You could argue this is unnecessary, but I do it just so you don't have a super sharp edge right on the end of the barrel. It's more of a convenience thing, to be honest with you, but again, you could crown your barrel however you like. Right then, the very last thing to do with the barrel is move it over to the mill and get the transfer port machined into the end. This is super simple. I just held the barrel using a collet block, centered up on the middle, then just located the hole. All I'm doing here is just drilling a 3mm hole in the end of the barrel, just using small steps in drill bits as to minimize the burr pushed through into the rifling. The finished hole will be 3mm in diameter and then finished off with a nice deep chamfer to mimic the original barrel. I did also flip the barrel over and create a small witness mark in the other end just so I had something to line up when I come to fit the barrel into the block. Right then, and there we have it, the finished barrel for the Theoben Rapid. What I've gone ahead and done here is just line up the two barrels side by side, and I'll get you a quick look at the measurements. So the new shortened barrel is around 35.5 centimeters, and the old barrel with the 1/2" UNF adapter on it is around 44.5. So the new barrel is about 90mm shorter than the old one. Now, some of you may be wondering, why didn't I just shorten the original barrel down to the new length? And the very simple answer for that is that the old barrel, this one here, is very good, and I didn't want to risk messing it up. I know this one shoots absolutely fantastically, so I didn't want to cut the end off and have the barrel worse than it was before. I'm sure nothing would have gone wrong if I did end up shortening it, but you can't add material back once you've cut it off. The only other thing I'll mention is that after the transfer port had been drilled, it did push a burr through into the rifling, which needed to be removed. What I ended up doing was just using a really small needle file just to remove the internal burr from the inside of the barrel, both through the transfer port, then very carefully coming through the end of the barrel and just removing the flakes of material. You'll know you have a burr on the transfer port if you can feel it as you push a pellet into the barrel, or if you end up rodding a pellet through the barrel. When you take a look at it, there'll be a mark on one side where the pellet has made contact with the burr from the transfer port. Right then, there we have the barrel fitted to the action. So I've gone ahead and checked the power, made sure it's set where I want it to be set, and I've also tested that we don't have a leak of air coming from the breech every time we take a shot. So the pellet probe itself is sealing against the barrel nicely, and when we push a pellet through either single shot loading or using a magazine, everything feels nice and smooth. The other thing I've gone ahead and done is fitted an offset shroud to the barrel itself. Now the shroud isn't working, it's just a dummy one. What I wanted to do is get the shroud to be a nice fit between the bottle and the scope. So as you can see there, we just have clearance on both the top and the bottom. And that's just a piece of 25mm carbon tube supported by a couple of offset brackets. So they were just something I 3D printed. You can see the one in the end just there. Right then, and with that all said and done, that's pretty much going to do it for this particular rifle. In the next video, what we're going to be doing is making a moderator for the end, and then the last video on the Theoben will be a review after a few months of ownership. But with that all said, that's pretty much going to do it for this particular video. Thank you very much for watching. I hope it's been interesting or useful, and I'll see you in the next one.